Hi, this is Mariam. I'm gonna today to revise with you integration by substitution, which we called U substitution. If you remember, we said when we can't solve or we can't integrate a composite function with our regular integration rules, we use U substitution, in which we recognize a pattern. For example, we are gonna to remember what's meant by U substitution using these two similar examples. In the first one, if you look here, you will find here x squared plus 1 cubic times 2x dx. To recognize a pattern, mainly to find an inner function, and this function is multiplied times its derivative. So here x squared plus 1 is multiplied times 2x, which is its derivative. Now our assumption is clear. Which is u equal x squared plus 1. Now take the derivative, du equal 2x dx. Let's substitute by u value, x squared plus 1 cubic, which is u cubic, 2x dx, which is du. Okay, integrate u power 4, and don't forget to divide by the new power, which is 1/4 plus c. Substitute 1/4 x squared plus 1. Again, we are going to substitute by x value, which is 4. The power here is 4 plus c. Okay, now to check our answer, we are just going to use the chain rule in differentiation. If you remember, we said that chain rule is comparable with U substitution. So in this case, we are going to use chain rule to differentiate this. 1/4 as it is. The power here is 4 times the power, which is 4. X squared plus 1. The power will be decreased by 1, which is 3. And the derivative of c, of course, 0 dx. Times the derivative of inside, which is 2x. 4, fly with 4, x squared plus 1 cubic times 2x dx, and this is the derivative of the function which we integrated here. Now let's look at this example. We said that it looks the same or similar to this example, but we are missing here what? We are missing here 2. This is x dx, and this one is 2x dx. How can we do this? I said it's looking like its derivative, but we need 2 here. Simply, we multiply times 2 and divide by 2. Okay, nothing changed. We multiply times 2 to find here the derivative of what's inside, and divide by 2 to solve this integration. We are going to do the same. U equal x squared plus 1, du equal 2x dx, and then substitute here. Don't forget 1/2 integration of u cubic 2x dx, which is du, and then 1/2 u power 4 divided by the new power integration power rule plus c. 1 divided by 8 u power 4, which is x squared plus 1 power 4 plus c. Again, let's use chain rule to differentiate, to check our answer. Check using chain rule. Outside times the derivative of inside. 1/8 divided by 8 as it is. X squared plus 1 power 4 will be 3, and multiply times the old power, which is 4. Okay, then multiply times the power of inside, which is 2x dx, and of course the derivative here is 0 of c. Now simplify. 4 times 2 equal 8, and we have 8 here, so exclude this with this will be x squared plus 1 cubic x dx. And this is the function which we integrated here. X squared plus 1 cubic times x dx. Now let's use u substitution in a trig function or an integration contains a trigonometric function. Here sine square 3x cosine 3x dx. In this function you can recognize the pattern that sine 3x, this is inner, its power is 2, and it's multiplied times its derivative, which is cosine 3x. So put u equal the inner function sine 3x. Find the derivative. Du equal the derivative of sine is cosine 3x, and remember that we have here 3x, so you have to multiply times the derivative of inside, which is, what's the derivative of 3x? It's 3, so about 3 here. Chain rule again. Now using this assumption, we are going to simplify our integration here. It will become what? Sine square 3x will be u square, and here cosine 3x. Look at this, cosine 3x dx here is what? Is multiplied times 3 here, okay? So cosine 3x dx here will equal du divided by 3. So when we are substituting here, cosine 3x dx will equal du divided by 3. Okay, now integrate. 1/3 will be outside the integration, and integrate u square will be u cubic and divide by the new power, which is 3 plus c. Now substitute by u value. Sine 3x cubic, and here 1 divided by 9, 3 times 3 plus c. Again, using chain rule, you can check your answer. First, differentiate sine 3x, which will be sine square 3x, and multiply times the old power, which is 3 over 9. Okay, and then get the derivative of inside, which is sine 3x. The derivative of sine 3x is cosine 3x times the derivative of inside, which is 3. Okay, here we have 3, and here we have 3, and here we have 9. Okay, so 9, 3, 3. We have sine square 3x, cosine 3x dx, and this is the function which we derived here. Okay. Another type which we are going to use u substitution when the function or the integration contains root. The same, the inner function here is what? 2x minus 1, to let u equal 2x minus 1. Then du equal 2 dx. Now substitute here. Integration. Root 2x minus 1, which is root u, which is u. And dx here, take care that we have here dx. 2 dx equal du. So dx equal du divided by 2. Now substitute. So dx equal du by 2. It's integration, but you remember when we said that we have here a root, we can rewrite it as a power, and root as a power is written as u power 1/2. Okay, and take 1/2 outside du. Let's integrate 1/2 u power 3 over 2, and the new power we have to divide by the new power, which is 3 over 2 plus c. 2 with 2, which is 1/3 u power 3 over 2 plus c, and then substitute by u value, which is 2x minus 1 power 3 over 2, 1/3 plus c. And also using chain rule, you can make sure that you solved it right, or you can check your answer using chain rule. So by this example, we solved 4 types of U substitution: trigonometric, root, and a function which can be rewrite a function to integrate it. But if you can't find the derivative, you can handle it. I mean, you can multiply or divide to make it similar to its derivative without changing the integration.